Welcome to Shiksharthi, and today's topic is Logarithms Part 2. In the previous video, you saw the rules of logarithms, the base value, significance of base value, and the basic introduction about logarithms. It can make the usage of powers easy, and you can also handle a big powers very easily with the help of logarithms. That's the importance of this topic, logarithms. So let us see what are the types of questions we can find in logarithms. There are two types of questions we find. One is simplify. The question will ask you to simplify the expression, or the question can ask you to find the value of x. So that means solve for x can be the questions. So in this video, I have taken few questions on simplification and few questions on solve for x. So let us start with simplification. You can see this question, all of you. Simplify, and the question you can see, and the arrangement of ABC in this question, if you observe, are in cyclic order in this case. That means in place of A, here the place B, and B is replaced by C. So ABC, 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 like that, the things ABC will be arranged in cyclic order. And this question, you see, the first term is with base A, second term is with base B, and the third term is with base C. All three of them, A, B, C, can be a same base or can be a different base, unless it is given as a condition. Fair? Now, what I can do in order to simplify this, I can write the same thing as log BC base A plus, I can write 1 as log A base A. You know the rules. 1 can be written as log n base n or log m base m. 1 by, again, log CA base B plus, this can be written as log B base B. The 1 can be written as log B base B. And finally, 1 by log AB base C plus, it will be log C base C is what you get here in this case. Fair? So all these things are given to us. Now, if you see in the first term, both the bases are same. I can write this as log ABC base A plus 1 by log ABC base B plus 1 by log ABC base C is what you get. Now when you reciprocal them, this will be log A base ABC plus log B base ABC plus log C base ABC is what you get. Now all three of them have the same base. Then I can apply this concept here. Log M base A plus log N base A is equal to, this will be equal to log Mn base A. Since the base is same, I can take them into single logarithm. So this will be now taken as log ABC base ABC, and the value for that is equal to what? 1. So here the simplified value of this is equal to 1. So let us see one more example, friends. Given log 8 plus log 25 plus 2 log 3 is equals to 18 is given to us. Is equal to 18 is given to us. Okay? Or minus 18, I guess. It's minus log 18 is given to us. Now let us see this. So what are given to us? Log A plus log B, if it is given, I can write this as single log AB. This I can write. And if it is log A minus log B, then it is log of A upon B is what you get here in this case. So they have this. So let us simplify. Log 8, I'll keep it as it is. Log 25, I'll keep it as it is, plus, if I send this before, so this is something like P log M, and that can be written as log M to the power of P. So power, this goes as a power if you see. The same thing I'll write here. This can be taken as log 3 square minus log 18 is what you get here in this case. And then friends, log 8 plus log 25 plus log 9 minus log 18 you have. Now applying these two, in an instance, a single logarithm of 8 into 25, when there is a plus sign, that will be multiplied, into 9 divided by 18 is what you get. Here minus sign, so minus sign will be upon B. So now you can further cancel this. This gets cancelled by 2, this gets cancelled by how much? 4. 4 times. So this is something like 4 into 25 is 100. And you all know it's by default a common logarithm. That means the base is 10 can be further taken as log 10 square base 10, and final step is 2 log 10 base 10, nothing but 2 is the simplified answer for this. So overall the simplified answer for the given question is 2. And some of the points which I instantly, like here I have added 10 base 10. You all know that common logarithms, by default it is common logarithms. If it is mentioned or not, here it is by default base 10, base 10, base 10, base 10 is there always in logarithms. Okay, that we should never forget while doing logarithms. Let's have one more example, friends. A similar kind, let us have one more example. Here we have the question, and first step what I can do, I can write 15 upon 18 whole square for this, 15 upon 18 whole square, and then minus log 25 by 162 plus log 4 by 9 here, and then is equals to log 2 is given to us. Okay, what is 15 square? So we have this as 15 square, or I never try to make the numbers big. My advice is sincerely, see, I know 15 square which is 225, I know 18 square which is 324, but is there any good use of them? Always try to keep the numbers small so that the cancellation or the dividing or relating with other numbers can become easy for you. So this I'll write it as 18 upon 18. Rather, I would also prefer to cancel 15 and 18 if you see. I would write as pi by 6 if you want. Okay, so better I do that. Okay, so better we do that. 5 by 6 I'll do it. Simple. I'll make it 5 by 6. This I cancel. It's pi times and this is 6 times. And then log here 5 by 6, that is 25 by 36 I can write after the square of the number. And then this is adding, you see. This and these are positive terms. So into 4 by 9 is what I get. And this one, since there is a minus sign, I should divide this whole thing by 25 by 162. Since there is a minus sign, I should divide by 25 by 162, or if I am multiplying it, it becomes reciprocal. We know indices, right? So according to indices, this is what we get, and this is something called log base 2 we have. And you now can do cancel whatever it is possible, like 25 and 25 gets cancelled, this gets cancelled by 18, this gets cancelled by 2, and this gets cancelled by 2, my friends. So you can see ultimately I am getting on the left hand side log 2, which I need to prove it. Fine. So I have proved it as log 2. The question was to simplify and get the value as log 2. So I got that as log 2. Okay. Next, if you see, given two values of log 2 is equals to, these are standard values of log 2 and log 3. If it is possible, please try to remember these numbers. It is 0.3010 and log 3 value is 0.4771. Always remember this. We'll have a more discussion on these things. Right now we just need to use them as a values and then find log 3.6, log 15 and log 2. Okay. So let us start with log 3.6, friends. Can be written as log 36 by 10 also. Can be written as log 36 minus log 10 also. This is by default base 10 and base 10. So you can understand it is 1. And now if you see 36, if you take, because I want to get the things in the form of log 2 and log 3, I want to get this 36 only when I divide by 2 or 3, like prime factor form. So if I divide 36 by 2, I'll get 18, again by 2 it is 9, by 3 it is 3. So what I can do, friends, this I can write it as log 3 square into 2 square. You can see it's 3 square into 2 square we have. Base 10 minus 1, because log 10 base 10 is equal to how much? 1. We know that value, right? So now if I expand this, I'll get log 3 square base 10 plus log 2 square base 10 minus 1, and this is 2 log 3 plus 2 log 2 base 10 and base 10 minus 1. So what is 2 into log 3? 0.4771 plus 2 into log 2, 0.3010 minus 1. and then we need to multiply and get the value. It is 2, 14, 15, 1 carry, and then 9, 0 point, and plus here 0206.0 minus 1 is what you get. And 20 and 42 is 62, 60 and 95 is something like 155. So 55, 1 point minus 1. So ultimate answer is 0.5562 is the answer for this. If you are not clear with the writing here, please, I would write it once again. This is 5562 minus 1. So final answer is 0.5562 is the value of log 3.6. So we need to find out log 15 now. How do we find log 15, friends? If I find log 15 can be written as what? Log 15 can be written as, this is log 5 into 3, and further can be written as log 5 plus log 3. I know log 3 value but not log 5. So for that I can write 5 as 10 by 2 base 10. 5 can be written as 10 by 2 plus log 3. So now it is log 10 base 10 minus log 2 base 10 plus log 3. And you know the values here. This is 1 minus 0.3010 plus 0.4771 is what I get. And then you know how to get the value of it. Fine. So final answer here would be 71 minus 10 will be 61, and 1 minus 0.661 in the last, and then 47 if I add, and from 47 if I subtract 30, it is 17 is what I get. So 17, if I take it 17 here, I'll get 17 over here. And then if you subtract, finally my answer would be 39, and 17 if I subtract is 83. 0.8339 is the final answer what I get here in this case. Fair enough? So similarly you can find 12. I'll give you a hint. This can be taken as log 2 square into 3. What is 2 square? 4. 4 into 3, 12. And then it can be taken as 2 log 2 plus log 3, and I can get the value of it very easily. So try that once. Next one, friends, given x is equals to 100 to the power of a, 10,000 to the power of b as y, and 10 to the power of c as z, and the question is to find the value of log 10 into root y upon x square and y cube. Okay, so let us see. So now see, the values of x, y, z are given, and the question is to find the value of this. And how do we do this? Let us expand this one, and moreover this is along with log. So I want all of these the values of log. So what I do, friends, x is equals to given 100 to the power of a, right? X is given 100 to the power of a, and then I can write the same thing now as log x is equals to a log 100. Similarly, y, log y can be taken as b log 10,000, and log z is equals to c log 10 is what you get. I got 3 values in logarithm, and the question is to find this. So in first step I can write log 10 into y to the power of 1 by 2 minus log x square z cube as a value. Denominator I can take it as minus log, and then this is log 10 plus log y to the power of 1 by 2 minus, this can be taken as log x square minus log z cube is what you get here in this case. And then it is log 10 plus 1 by 2 log y minus 2 log x minus 3 log z is what you get here. Now this one is by default base 10. This is 1 plus 1 by 2 into log y. What is log y? You can take here b log, you can say 10,000 as 10 to the power of 4 as well if it is required, minus 2 into log x. What is log x here? A log 10 square I can take, minus 3 log z is given as c log 10 is what you get here in this case. Okay, so few changes I got it, so that we can see 1 plus this. If I open it, what I get here, this 4 will come in front of it, so 4b by 2 log 10, and by default base 10 it is, minus this 2 will come in front of it, so 2 into 2 4a log 10, and by default the base is 10, minus here this is 3c log 10, and by default it is base as 10. Now all these three values, log 10 base 10, log 10 base 10 and log 10 base 10 will become 1 as we know the rules. Then 1 plus 4b by this I can cancel by 2. So I can simply write it as, instead of 4b by 2 I can cancel this by 2, and I can simply write this as 2b minus, here this is 1, so 4a, and the final one is 3c. That is the simplified value of the given in terms of ABC. So question was to get in terms of ABC. So my final answer is in terms of ABC. That is what we need to check. Okay. So let us see the other question, friends. Given a square plus b square is equal to 23ab, and this is what we need to prove it. Fine. So fire, given a square plus b square is equals to 23ab, I'll add ab, 2ab. I'll add 2ab on right hand side and 2ab on left hand side. You know what happens? This will become a plus b whole square, and this will become 25ab. And then applying log on both sides, log of a plus b whole square is equals to 25 log, or you can take it as say log 25ab is what you get here. And when you open the bracket here, it's 2 log of a plus b is equals to log 25 plus log a plus log b is what you get. And this is 2 log of a plus b is equals to 25 can be written as 5 square. We all know that it is 5 square. So it is 2 log 5 plus log a plus log b. Now according to the required answer, we can remove the things, or we can do further anything changes it is required. Fair enough? So what is required here? Sending this to the other side, it is 2 log of a plus b minus 2 log 5. See, based on, see, right hand side, if you observe, there is only log a and log b term we have it, right? So here we have log a and log b term. So this is log a plus log b is what you have. Now taking 2 common, it is log of a plus b minus log 5 is equals to log a plus log b is what you get here in this case. Okay. Now further what? Sending this 2 to the other side, you'll get log of a plus b, and you see minus 5 was there, so that becomes a minus 5 over here as a base, or the denominator by 5 will get it, is equals to, sending this 2 to the other side will be log a plus log b whole value half 1 by 2. And that was the final thing what was expected. You can see this final answer what is expected, log a, log of a plus b upon 5. So we have the same answer, we got it here, log of a plus b upon 5 is equals to half of log a plus log b. Okay? So this is how the next question, let us see. Good question. Log 36 square base 6 plus log 36 to the power of 2 by 3 base 6. All of them have base 6. So we can apply the logarithm rules over here. I can write this as 2 log. It's like 2 log 36 base 6 plus 2 by 3 log 36 base 6 plus, and further it will be 2 by 9 log 36 base 6, and so on up to infinity. You have it here. Right? Now I'll take here log 36 base 6 as common. You see, in every term there is log 36 base 6, right? And that can be taken as now 2 plus 2 by 3 plus 2 by 9 plus so on up to infinity. And this is geometric progression series, correct? This is a geometric progression series. We'll apply sum to infinity, that is a by 1 minus r, where a is equals to 2 and r is equal to 1 by 3 we have. So apply that here. A is equal to 2 by 1 minus 1 by 3 into log 36 upon, base 6. So this is 2 by 2 by 3. And the further this also can be written as log 6 square base 6. Log 6 square base 6. Now the final steps, all of you. This is 2 by 1 into 3 by 2. So it is 2 by 1 into 3 by 2 into 2 log 6 base 6 is what you get here. And now you can cancel the further things here. This gets cancelled. Answer 6 into 1. Final answer is how much? 6. That's your answer. Okay. So now let us see, all of you, the next question here. So let's see now, solve for x. Very simple question here. Log of x square minus 21 is equals to 2. Can I write log 10 base 10 over here? Because 2 into 1 is nothing but by default the base is 10. We all know that, right? So this can be taken as log x square minus 21 base 10 is equals to log 10 square base 10. Now both the sides the log is base 10. I can remove them and I can simply say x square minus 21 is equal to 100. X square is equals to, what do you get? 121. I'm sorry, this is 121, and the value of x will be how much? If the value of x can be taken as plus or minus 11. Generally it is plus or minus 11. Now while applying plus 11 and minus 11, we need to take care of one thing. Because of the square here, you take plus 7 or plus 11 or minus 11, the value will always be positive. Remember, logarithm is applied only on positive numbers. So if I take a plus 11 here, this is 121 minus 121. Minus 11 also gives you the same thing. So it can be plus or minus 11, valid answer. Okay. So sometimes what happens, minus 11 may give you a negative value for this bracket. So logarithm is not defined for negative values, that we need to remember in this case. Okay. So next one, this. Here, if I can take this as log, or if I if I convert this into logarithmic form to exponential form, this is 5x minus 6 is equal to x square you get, and the very simple thing, x square minus 5x plus 6 is equal to 0, and the value of x minus 3x minus 2x plus 6 is equal to 0. I'm doing a factorization here, we all know that, x square here. And taking x common, x minus 3 minus 2 common, x minus 3 is equal to 0. Ultimately x minus 3 into, example friends, this one. If I take this into exponential form, it will be 5x minus 6 is equal to x square. And there you see a quadratic equation has come as x square minus 5x plus 6 is equal to 0. And while after factorizing, you get the value of x as 3 and 2. You know how to factorize the things, right? Next example, this one. This can be taken as log of x plus 5 into x minus 5 is equals to log 2 to the power of 4 plus log 3 square you get. In one step, a lot of things can be possible. And this is log of x square minus 25 is equal to log of 16 into 9, and we got a single log for them. So we can eliminate log on both sides. X square minus 25 is equal to 16 into 9 is 144. We know that, right? So x square minus 144 to the other side, or x square is equal to 144 plus 25, which is 169, and the value of x can be plus or minus 13 you get. Now the point is, can I take plus 13 and minus 13 also? If I take a plus 13 over here, 13 plus 5, 18, 13 minus 5 is 8. Both are positive values. Logarithm is defined for positive values. If I take minus 13 plus 5 is minus 8, and logarithm cannot be defined on minus 8. So the value of this cannot be taken as negative. So I just eliminate the negative part of it. That's it. So it can be only plus 13, not minus 13. So the value of x here is only 13. So keep practicing all these questions in the video, and also try to solve the similar kind of questions which can be available in other sources. Okay, so thank you all, practice well.